Hi everyone. It's great to be with you doing this virtual Ortonville Summer Rec program. We're glad that you could join us. My name is Kara Greger and I am from the Ortonville High School Robotics team, and then I also work with the 4-H program and do robotics and engineering and design program for the 4-H robotics in Big Stone County. And so I'll let my partner in crime introduce himself.
I'm Robert Angelo. I'm part of the Ortonville robotics team. This is my mom. This is my mom. She's actually the coach.
Yeah. So today we're going to talk about engineering and designing. We are asked to talk about robotics, but we're going to kind of talk about engineering and designing, which is a really important part of robotics. Because if you design and engineer your robot, well, it works much better. So we're going to have a couple different activities for you to do today. Robert is going to lead the ripping rockets demonstration. It's an activity you can do with simple things that you have at home, and you will also get this nice sheet that'll tell you how to do it. And then the second activity we're going to do is we're going to make skimmers. And what we do, we make paper skimmers, and it teaches you about wind energy and how to harness the power of wind energy with the design that you create. So I think we're going to get to it. Do you want to start working on ripping rockets?
Yeah, let's go. Hi, I'm Robert. Whenever you blow up a balloon, don't you want to control its direction? Because most balloons are just like, they go wherever they want. They don't go straight. Well, I'm going to teach you how to make a rip-in rocket, which can actually control the direction a balloon goes. Now, this is a packet that you should get for it. And I'm not going completely by the directions, because when I did, it didn't really go in a controlled direction because there's too much weight to it. So I'll go by my way, but it is going by some of the directions. So first off, you'll want to cut 1 inch of a straw, because you'll need 2 straws for this. So I'm just going to measure that and cut it. So you have a 1-inch piece of straw, then you have a second one. Now what you want to do is grab a balloon that you have. You want to inflate it before you do it, probably with a rim on it. And I use water balloons because they can easily fit around these straws. Now the directions say to cut the rim off of a balloon. And to help inflate it, I would just like lengthen it out, make it easier. Now, what you want to do is put the end of the balloon inside of the straw and not fail doing it.
That's not failure, you just dropped it. And you picked it right back up.
This might be the hardest part.
Yeah.
Because it likes to not do it.
It's very delicate.
Yeah, it's very delicate.
And here's one that's completed. This is what Robert already put together. So you can see how that 1 inch, there's not much sticking out of the top of that side straw.
When you use it more often, it is easier to go. So the more you do it, because the balloon gets more elastic.
Flexible,
yeah, flexible. That's a good word. Now what you want to do next, once you get the balloon on the straw, you want most of the balloon on the straw. Like you can see, this is the rest of the straw. You want to put a piece of tape and wrap it around the straw so then it sticks like this. And
You can see it on this one really well too.
yeah. And then next, you would want to tape the straw to the next part, as you can see here.
Is it on the bendable side or the non-bendable side of the straw?
It's on the bendable.
Okay, yep. Just like this one too is that same way. That's the bendy side of. So you want bendable straws. Make sure you purchase bendable straws.
And then you put a piece of tape around that. And then once you have this, then you grab a piece of paper. You can see in the directions it says to have a 3x3, or you could measure it off and make like a wing type part and like cut it in half.
And you could decorate this too
Yeah,
if you wanted a fancy thing. And with the water balloons, this is Kara, Robert's mom. I'm on the other side of the camera right now. But we did try bigger balloons, but they didn't fit as well around the straw. So maybe if you have big straws, you could use bigger.
Yeah, these were our other balloons. They are easier to inflate, obviously.
But
yeah, they don't fit around the straw
as well,
as you can see here.
Yeah.
But if you grab bigger straws, you can definitely use these. These would probably work better.
Yeah.
Okay, and then once you cut your wing of paper, then you tape that to, you kind of want it like this. So then the balloon is like, it goes down the side and then the paper is on the opposite part. Like that. And then you have your rocket. And so there's a trick with inflating these, because it is kind of hard to inflate it with this straw in the way. So what I've just done is just bend it. Just bend the straw. And then I'll let it go in here. And you see that goes straight and is very controlled. I see the other balloon also got there, but trust me, you probably didn't see it, but it was spiraling around. So yeah, that's how you make the controlled. If you want a balloon to go in a straight line, you can use the Ripon Rockets balloon.
So what are some of the concepts that you learned from this project?
So the kind of forgot.
The propulsion?
Yeah, so the balloons, because of the air in the balloon, it shoots it out and makes it in like a straight
forward,
line. Yeah, because of the weight is just enough so that it goes straight. And with a regular balloon, because there's no like really target, like no weight to it, it just spirals around.
Yeah, and what are some of the questions that can be asked of your student to kind of get you thinking about design and...
So what you can do, I never really read this. So you can reflect upon how did you and your friends, if you be sure that you social distance if you're doing this with friends, or if you're with
Zoom.
family.
You could do Zoom.
You could do a Zoom meeting. So how did you and your friends' results compare? So you can compare your answers if you want. And what did you learn about directional control of a rocket? It's kind of like we said, it kind of controls the direction of where the balloon is going. And you can apply on what you learned about conducting an experiment. Like we have, you can do a hypothesis before this. Think of what a regular balloon will do, and then what you think the rocket will do. And then lastly, you can see how do experiments help to solve problems. There are many times in science you might do a science fair at school, which is all about an experiment. You have a hypothesis, you have conclusion, you have your actual testing part, and there are a lot of different steps in that.
Yeah. So in other things, we learned the 2 straws didn't work very well for us, and you could change your tail to make it a different size, and maybe that would affect how far it goes.
If you want to, you can actually try doing what the instructions say and not do what we did and see if it affects it at all.
Yeah. Yep.
And yeah.
Sounds good. So now we're going to take a pause, and we're going to take our rocket outside for a little bit, and then we'll go on to the skimmers.
Whoa, we're outside now. Wow. Okay, let's test these balloons. So this is the water balloon that's filled up with the air. It is hard to inflate, like I said in the previous inside. So we'll let this go and see what happens. See, very uncontrolled. And now let's do a regular balloon. Okay, we have our regular balloon. Let's see what this does.
Ooh, this kind of flops.
That is kind of more contained, not as wild. And now let's try the rocket. We'll aim it in the direction of the wind, because that'll probably be easiest.
It's a northeast wind.
Yeah.
That'll help too. That'll probably help it go farther, you would think. Wow.
These sometimes pop and it's like right in your ear, so don't do that. Okay, let's see how this does.
Straight.
Now, you can see that is more controlled than the other water balloon. This one, the actual balloon, yeah, that just likes to go straight up. Okay, this has less air. Way less. Okay, let me reinflate it. Okay, let's see how this goes.
Oh.
That wasn't that much air.
So it needs more air. What happened before when you were practicing? You had one.
Well, when I had one of the actual balloons, is that what you're talking about?
No, I think it was the rocket. Wasn't that yesterday when you did the rocket, it went on the roof?
Yeah, I had one. I wanted to show it off to my mom. So I let it go outside, and it went straight up and onto the roof. So, those were good times. We had to grab the ladder. But yeah, thanks for coming outside with me and seeing how these balloons go.
Back again, it's Kara. And so now we're going to talk about skimmers and how to harness wind energy. This is a fun thing we've done at the 4-H Robotics program for the kids. It's 3rd grade through 6th grade at the Ortonville Library, January through March. So this is a fun activity we've done to teach kids about harnessing the power of the wind by designing a paper skimmer, however you want to design it. And so what you'll need for this project is you'll need cardstock is preferred, and then also just regular paper. You can use that too, but the cardstock works really well for kind of your base. And then just different household items, straws, popsicle sticks, paper clips, sometimes note cards are good. You'll probably want scissors. You want some tape is a good adhesive to use. You can use clips, binding clips. Fasteners are another thing that people will use. So just any kind of household item to put together a skimmer. And you can go as fancy or as low-key as you want. I've seen lots of different designs for skimmers over the year. And the fun thing about it is you can start with something really simple, maybe just like make a boat out of a piece of paper by, folding it. You can fold it in different directions. This is how I started mine, was just kind of folding it in different directions, and you can measure, you know, maybe you want it 2 inches on each side or something like that. And then this is your skimmer. You can try to use it this way, or I went this way, and then I put a sail on it. And I just did a rectangular sail, but maybe you want to try a triangular sail. So you can do all sorts of things, and it's really an inexpensive thing to do. You will need a fan too. We have found box fans work better than like oscillating fans when we tried it with the robotics kids. So we'll use this first paper one, just plain, and see how that goes. And we can see how we can harness the wind best. Is it better to go this way or that way? And you can document this. Write down how you're experimenting and how many experiments it took and what you found to be the best design. Okay, so let's try this one. We'll see what happens when we turn the fan on. And usually we have contests to see whose skimmer can go the farthest. And the kids really love that. So if you have more than one kid, you can have competitions, which is fun. Okay, let's see what happens to our skimmer. Oh, that one's not really going, is it? Let's see what happens when we turn it that way. Yeah, not much is going on. Now let's try our one that we designed. Let me put it down there first. I also added paper clips to it, and I put some straws in the middle to kind of give it some structure so it doesn't just flop over. So, as you can see, we have a few design flaws that we've been trying to work on. It seems like our skimmer keeps turning to one side, so we're trying to see if we need more weight on one of the sides. Robert and I have been working to try to get the right design. But so how this works is you just keep experimenting, keep adding things to different areas, and then analyze. So why is my design not working? Robert and I why does it keep turning to I think it's turning to the left. Is it a weight issue? Do we need to put our weight in different locations? Do we need to take weight off? And just kind of keep reevaluating what is causing your skimmer not to go in a straight line, or why is your skimmer not able to make it to the end of the table. That's kind of what we do during the robotics class too. So this is a really fun thing. You can decorate your skimmer. I haven't even touched that, but you could put a nice picture up there if you like to draw. So yeah, so just another experiment with our skimmer here. Let's see what happens. It took off some weight. See, now it turned a little bit that way. So I like to just help it along. See, there, it went really far. So that's skimmers, and that's how you can create a paper skimmer with your kids. That's how you kids can work on this project. Just get some cardstock, some popsicle sticks or some kind of stick. You could even find a stick out in the yard, you know, what the heck. Straws, paper clips, tape, things that you have in your house. So I hope you have fun with this. Keep experimenting and learning and figuring out a good way to design the best paper skimmers, and post it online and share it with Summer Rec, because that would be really fun to see all your guys' skimmers and what you've created. So that's the skimmer portion of our video. Thanks.
So thank you for watching our videos about wind power. I hope that with the balloon rocket experiment, I hope you learned about the directional control on how rockets work and how to conduct an experiment.
Yeah, we really enjoyed doing this with you. How to harness wind energy with a paper skimmer. I can't wait to see all your paper skimmers and what you do with them. Keep a log, keep experimenting, keep asking questions. There's lots of different things you can do out there, and we really enjoyed having you with us today. So take care. Yeah. Happy experimenting.